Hello and welcome to my YouTube channel. Today I'll be talking about semiconductors, and it has been a long time I've posted a video onto this channel. So today I'm making this video on semiconductors. And when it comes to semiconductors, we can analyze it by looking at its atomic structure, right? So if we talk about a semiconductor, a good example is going to be a silicon. We have another one which is what, uranium. So we have two commonly known semiconductors, and they are silicon and then germanium. So when it comes to any semiconductor, for that matter, they tend to have 4 valence electrons. So we can sketch the atomic structure of a silicon atom, which is being shown here, and you can see that some 4 valence electrons. So we've only indicated the 4 valence electrons. So the inner shell electrons are not being indicated. And then with this, when it comes to any atom, we know that it's going to we have electrons that are orbiting around the nucleus, and within the nucleus we have protons and neutrons, right? Now, when it comes to this, we can now talk about the kind of structure that we can get when you have, for example, several silicon atoms are being combined together, right? So we have the structure that is being illustrated here. You can see here, if we have 4 valence electrons, right, these 4 valence electrons are going to be shared with neighboring silicon atom. So you can see here in the middle, if you see the structure in the middle silicon atom that we have here, you can see that its 4 valence electrons are being shared by neighboring silicon atom. So as a result of this, you have a covalent bond that is existing between the silicon atoms, right? And this covalent bond is a very strong bond. So it's going to be hard for you to break through this covalent bond. And also to do that, you require a lot of energy, right? You require a lot of heat in that process. So we refer to this as as a tetrahedral structure. And from here, we can talk about the properties of semiconductors. So one property could be that they tend to have 4 valence electrons. And you can also increase the conductivity of a semiconductor through the process of doping, right? So through doping, we can enhance the conductivity of a semiconductor. And if you look at the structure again, remember that we talked about the fact that we have a covalent bond that is holding these silicon atoms together. In order for you to break through this covalent, you can also increase the temperature. So increasing the temperature will reduce, right, the resistivity, right? So if you increase the temperature, that will reduce the resistivity of the semiconductor. And when it comes towards the resistivity of any semiconductor, it tends to be high compared to that of a conductor. And then they also have a medium conductivity. So that means their conductivity tend to lie between that of conductors and conductors and then insulators. Right. So these are some of the important properties of a semiconductor. And then from the next video is going to be on doping, and then how we can enhance the conductivity of a semiconductor. Bye-bye.